out there's a bit of a lag at the start and the end. That's why it'll seem weird at the end as well. Just me staring into the screen for 20 seconds.
All right, well, we'll get this show on the road. We are live. I know the moderator that was on this call, I believe, had little technical issues. Will be joining in just a moment. So I'll just take over for just a moment. So thank you very much, everyone, for joining us today. Again, for this next session. Yvan Gauthier will be our speaker for this session. Yvan, I will let you present yourself, and then you can go on with the presentation that you have lined up for us.
Perfect. Thank you. And thank you to the organizers for inviting me. Really happy to be here today. So my name is Yvan Gauthier. I lead the AI Accelerator at the National Research Council of Canada, the NRC. And the Accelerator is a new capability that was established last year to help other Government of Canada departments and agencies with their use of AI and their digital transformation. I will tell you more about it later in this presentation. But what I would like to start with is a little bit of context around the use of data and AI in the Government of Canada, some of the challenges that the departments and agencies are facing with their adoption of AI, what we do at the NRC to help them out. And I will also, in the second half of my presentation, discuss some of the lessons that we learn by helping other government departments, and also in the process give you some examples of projects that we've done with some of our partners. And we're gonna have plenty of time for questions and discussions at the end. So I will use the term AI a lot today, and AI can mean a lot of things to a lot of people. It's always hard to find a definition that makes everybody happy. But for our purposes today, we will define AI as any technique allowing a computer to learn from data and mimic human behavior. So not only deep learning or machine learning involving deep neural networks, but any computational or statistical technique that enables a computer to solve a problem, answer a question, make a prediction, recommendation, or understand natural language, for example. So that's the first thing I wanted to clarify before we start. Another thing I should clarify is the fact that AI is not new to the government of Canada. And I often hear people talk as if data analytics and AI are these new great big things that just started to be used in the government a few years ago. And you know, it's not true really. The National Research Council has been in that space for at least 30 years, but you can go even further back. I'm going to show you a picture here. A picture of Dr. George Lindsay. He's a scientist who worked in the Department of National Defense for almost half a century. He basically built the organization that was part of before. He's one of the fathers of operational research in Canada. And this is him at the beginning of his career during World War II, when he was working on predictors. And predictors are the fire control systems that were processing signals from the first generation of radars and using that data to predict the motion of German aircraft and basically shoot at them automatically. So the predictors were mechanical systems before they became digital, and that's how George Lindsay described them in a paper he wrote about 11 years ago. He said that today such problems would be classified as artificial intelligence, and he was right. Some may call that prescriptive analytics or automated decision making, but the fact that this was being done in the early 40s is very impressive. And I could give you many, many more examples of that kind of data analytics that were used in the government of Canada over the years, not just in a research context, but in an operational context as well, to support very important decisions. So AI is really not a new thing to the government. What is relatively new, however, is the level of ambition for data and the digital across the federal government. So many strategic documents have been produced in recent years with the goal to make the government an open and service-oriented organization that operates and deliver programs and services in a simple, modern, effective way that is optimized for digital and available anytime, anywhere, and from any device. That's from the strategy documents. So that's very, very ambitious, and that means a lot of changes in business models, and there's challenges that come with that. This transformation will force us to devise new ways of exploiting an exponentially increasing amount of data. And we basically have two choices here. We can draw on in all the data that digital transformation will bring, or we can really harness and leverage that data in a responsible way to better serve Canadians and design better policies and ensure that you know, the security and the prosperity of our country. That's what we need to focus on. So one result of all these strategies is that there are several organizations and communities and policy instruments and working groups that have been created in recent years. And you could say that the data ecosystem of the federal government has grown very rapidly. And that's all very positive. It's much needed to succeed in digital transformation. Now, that said, there are many challenges that remain. And it's clear that, for example, the pace of digital transformation is very, very asymmetric. First, between the public sector and the private sector, but also within the government. So some departments are making progress very, very fast, and others are still contemplating the problem for various reasons. Data maturity, in particular, varies widely from one government organization to the other. Of course, if you're a department like StatsCan, Statistics Canada, and you've been in the data space for 100 years, you know to do data management and metadata management and that sort of thing. But if you're a small agency, you may not have that all that expertise, and that's becoming a problem for some organizations. the recruitment and retention of data talent in the government. There's good progress on that, but it still remains very challenging. And at the end of the day, if you want to deliver on all these data strategies and digital strategies, you need talent and you need expertise, and that's where that's where some departments have, I guess, a lot of challenges, and that's where we can help as well from our side at the NRC. Because at the NRC, our mandate is threefold. We do research, of course, that's in our name here. Part of our mandate is to advance scientific and technical knowledge. But we also exist for supporting the government and advancing the government policies. And we also exist to support business innovation. And when it comes to data analytics and AI, we've done a lot of projects over the years, both for the private sector and the public sector. Specifically, the digital technology division that I'm part of, our focus is to make digital technology smarter and more intuitive. We have 100 specialists at various places in the country with a lot of expertise in different areas, including machine learning, text analytics, natural language processing, text translation, you name it. We have experts in pretty much every digital area. And like the rest of the NRC, we are there to do research, yes, but also to support industry and government organizations. And when we talk about support to government organizations, there's a long list of things we worked on recently. You don't have to read them all, but the list is interesting in the sense that it shows you the kind of problems that are often faced by the departments. You can really bin the projects into different categories, and it's very telling. So we have organizations that are really just entering the data space and the analytics space, and they need help, and we've done that kind of support. A lot of organizations are basically trying to improve situational awareness, and this is something that AI is very good at, improving awareness, doing outlier detection and that sort of thing. We have more and more departments who are into IoT and sensor data that they want to leverage. I'll give you examples later, but leverage sensor data for maintenance, for example. Of course, there's the service delivery aspect of things. A lot of departments are focusing on that, but internally they do have services as well to deliver and all kinds of business processes, and we've been helping some of these departments with that. HR, a lot of problems are coming from the HR side. Text translation is an obvious one. So anyway, that's not an exhaustive list. There are many other things we've been doing, but it still gives you a sample of what we've been doing. And at the end of the day, it's still a very small slice of everything we're gonna have to do as an institution to proceed with our digital transformation. Now, I'm gonna go now into the kind of vehicles we use to help our partners with their digital transformation problems. Because we have different ways of working at the NRC. One of them is the collaboration center model. So the idea there is to co-locate NRC researchers with our partners from academia, industry, or government to deliver world-class, excellent research. And a prime example of that is our latest collaboration center in Waterloo, where the focus is actually on AI and IoT and cybersecurity. And our people there work on all kinds of interesting projects. For example, quantum safe blockchain that can be used for critical infrastructure, or automated material discovery using deep learning. We also have the Cybersecurity Collaboration Consortium in Fredericton. And as the name suggests, this collaboration center is really about advancing cybersecurity and its application to privacy and safety, including work related again to critical infrastructure protection, smart homes, smart grids, and that sort of things. We also have at NRC what we call challenge programs. Challenge programs are more centered around high risk, high reward type of research, research that has the potential to be highly transformative in addressing Canadian priorities. For example, the High Throughput and Secure Network Challenge Program. This is about developing technologies that will enable network operators and service providers to offer secure, affordable, high-speed internet services in rural areas and remote locations across Canada, which obviously, this is a government priority, and it's also essential if we want to serve all Canadians with digital services. We need to be able to have the pipes and the bandwidth to connect to them. So that's a good example of challenge program. And we also have vehicles that are more technical services, including services specifically focused on supporting the federal government. So as I mentioned before, last year, we launched this new capability that is the AI Accelerator. And the idea with the accelerator is not only we want to remain the go-to center of AI expertise for other departments, we want to be even better equipped than we were to help them address some of their challenges and help them through their AI journey. So the idea behind the accelerator is that we can help other departments to develop in just a few months solutions that will be very impactful, so solving real problems, solutions that will be, of course, innovative, but also responsible, because we want our AI solutions to be safe and ethical and transparent. That's what Canadians are expecting from their government. And the way we work is actually pretty simple in the accelerator. First, the departments who have an AI problem project, they just come to us, talk to us. We don't have an annual call for projects. They can come at any time, and we have a discussion. And then we move into an exploration phase during which we scope the problem with them and we explore their data. That's super important. We explore their data, and it takes a few days normally to do that. And we do that at no cost. But the idea there is to basically look at the feasibility of some ideas that our partners have. So at the end of a few days, we're able to tell them, for example, yes, you have a problem that is ripe for AI, and this is the kind of techniques you could use. Or we say, no, you don't have quite the data to do what you want. Or we could say, hey, there's a solution that already exists for this. It's off the shelf, you can buy it, or this other department has done it, maybe you should talk to them. That's the kind of things we do at this stage. But if the outcome is that, okay, yeah, there's an AI problem there, there's an AI solutions that can be built, but it needs to be custom and it needs to be, built just for your problem, then that's how we get into solution mode. And normally we take about 3 to 6 months to work with the client, and we do that on a cost recovery basis because we have to recover part of our cost at NRC, but we do that based on pre-approved rate at the Treasury Board. And at the end of these 3 to 6 months, the idea is to get deliverables that can be of different nature, but that will have an impact on the department. So most of the time, it's a validated model, an AI engine, if you want, that they can deploy in their own system. In some cases, it can be just a technical report or an interactive dashboard or even a strategy. We've done that before. But again, the idea is to be useful here. It's not just to produce a research paper, it's to have a useful product that can help the other department and advance their adoption of AI. That's what we're shooting for. So I will switch gears a little bit here and go through a few lessons learned and things we learned in the process of helping other departments over the years. And in the process, I'm going to describe some of the projects we've been doing, and hopefully you'll find that useful and hopefully a little bit entertaining as well. Starting with first lesson here, which is that, you know, adopting AI technology in a government setting is it's very hard. And here I'm not talking about just building a model, a prototype, you know, machine learning algorithm in Python. That's relatively easy. I'm talking about inserting AI into a digitalized business process and putting it in production to really serve public servants or serving Canadians. A big mistake that a lot of organizations have made, not just in the government, but in the private sector as well, is to get straight into machine learning and deep learning. And honestly, that's not the easiest place to start. I often like to say that the first rule of machine learning is do not start with machine learning. There might be simpler approaches to using your data that will address your particular business problem. And that will be much easier to implement and much easier to maintain on the road, and ultimately much more likely to succeed. And if your organization is new to AI and has never done this, what you need to aim for is really to get a quick win and get some momentum and get something that will help you refine your requirements in terms of IT and data and talent and expertise and so on. And to do that, it's always better to start small. So as I mentioned earlier, you know, AI goes beyond machine learning, and although we often end up using machine learning techniques at NRC, we generally do not start there. When we look at a problem that is brought by another department, we often start with simpler methods, and if necessary, we eventually end up to machine learning methods and more sophisticated algorithms. But this is not generally our starting point. Along the same line, the second lesson here is carefully select your AI projects. You really have to prioritize what you're going to do. Again, especially if you're starting in that space, be very careful. And there are different ways of prioritizing, but one approach that we often use is a metric approach that is partly based on industry best practices, but we essentially try to assess the feasibility of a project or potential project and its potential impact on the government. And of course, we also look at the amount of resources that each project may require. But you know, in that case, you know, you're trying to be as systematic as possible without going crazy and spending like several days analyzing each project. You can still compare projects very quickly. And there's a number of feasibility factors and dimensions that I'm not showing you here. It's not just about putting bubbles on the chart. There's some rigor behind this. But if you can, the idea is to find high impact, high feasibility use cases as much as possible. And if you can do that, you know, you will end up maybe with a few quick wins that will be much easier and much faster to deliver, and these will be successes. They will convince your leadership that, yeah, you need to continue. You need to have the more funding to continue these things, and you really don't want to waste your time on some of these money pits or, you know, big enterprise projects that, at least not as a start, that may or may not deliver or may create all kinds of problems for you. So start small is my message here. You have at the same time, be careful. You have to be careful and be aware of the hype. There's a lot of hype around AI these days. It's being fueled by the media. It's being fueled by the vendors of software. And seriously, there's a lot of snake oil that is being sold. And again, you have to be very critical of what is presented to you. I'm going to give you one example. all the cloud vendors right now are basically selling automated machine learning tools, and many software vendors and BI tool vendors are selling the same kind of tools, call them auto ML, and basically it's software that will generate predictive models for you in just one click. You just put your data in and the model comes out. And we played with a lot of these tools at the NRC. We even designed an experiment that compared several of these tools with with what a typical data scientist would build with a simple model, and also with what a Kaggle winning data scientist would build with a more sophisticated model. And even for very simple data sets with just a few variables, the AutoML started to struggle in some instances. In some cases it did well. It still underperformed humans, but for more complex data sets that contain hundreds of variables, really these tools didn't do so well. They often generate predictions that in some cases they fail to generate predictions. In some cases they generate big ensemble models that cannot really be explained, black box things that really will be in many scenarios be useless, because if you want to do responsible AI, you need to be able to explain what's going on, and in a lot of cases these tools will not help to do that. So bottom line here is I think the job of data scientists are safe for a while, but more importantly, I think we as public servants, we really have to educate ourselves, and we have to educate our leadership, not only about what AI can do, but about what AI cannot do. And this is one of these things where, AI is good, but AI building AI tools it's not quite there yet. Again, I'm trying to follow a logical order here, but better data is more useful than a better algorithm. Most of the AI libraries that you're gonna find out there, they're open source, and there's really they're not a source of advantage for you. The advantage is in the data you have, and to get better insights, you need to get better data. And if you've been following what Andrew Hing from Stanford has been doing with his data-centric AI movement, it's exactly that. It's to convince people that if you have a certain model performance, if you want to get better performance, it's better to get more data, more quality data than just more sophisticated models that may become less explainable because you just make them more complicated. Now, getting the data in the right quantity and the right quality, that still takes time. It's still what data scientists think it's taking the most time, but that's what you need. And if you want to build a good model, you need to invest a lot of time in your data. But here's the good news, though. In some cases, AI can help you get the data you need, and it can even teach old equipment new tricks. This is an example of a project we did at NRC. The idea was to work with analog equipment, gas meter readings, to be specific. As you can tell, there's a lot of analog equipment out there that would be extremely expensive to replace. As much as we want to live in a digital world, there's a lot of analog equipment there that is prohibitively expensive to be changed. And if we want to go digital with that, there are ways to do it, and we can use AI and couple that with machine vision. And in that case, we built something that basically take a picture of a meter and automatically translates it into a digital signal. We have a data set that we have open sourced around that, and I think it's a little known avenue for digitalization. It's to just not think only about the digital equipment we're going to buy in the future, but about all the old equipment that we have and that could become smarter with a little bit of AI and generate the data we need to monitor things and do a better job at at exploiting the data that is available out there. I'm going to give you another example along the same lines. Navy frigates, they collect over 2,000 data point every half a second for different pieces of equipment. I'm not even talking about the radars and whatnot. I'm talking about sensors on the engines and the transmissions and whatnot. This data until recently was largely underexploited. And the original intent was to make predictions and do predictive maintenance with it. But what we realize, and that's the lesson here, is that inferring causes is often more important to decision makers than making predictions. We often think about AI about, okay, this is about predictive modeling. We want to see the future. Sure. But sometimes understanding what's going on has a lot more value. And this is one of these examples. With causal models, we can now trace when there's a failure, we can trace back to the root cause of that failure and help the Navy figure exactly what piece of equipment is breaking. And that has a lot of value for them. And still at the prototype stage, but nevertheless, it's very promising. And once we do that, then we'll also be able to move into a predictive mode and use that for predictive maintenance and say, okay, here's what may fail in the future. And if you're about to change that engine, well, why don't you change this piece X, Y, and Z at the same time? Because the ship will deploy after that, and it's going to be too late. So a lot of value in causal inference that is being recognized now, and you're going to see a lot of stuff around that on the internet. I'm going to give you another example. Similar example related to the Public Service Employee Survey, which is a survey that all the government employees have to take in Canada almost every year. Every single department and agency have to look at the results and build an action plan based on the results. But oftentimes people don't understand what are the results saying, because some questions can be pretty vague. Some questions are, for example, I'm satisfied with my department, or here's another example, my workplace is psychologically healthy. So, okay, what if it's not? What if people say, no, my workplace is not psychologically healthy? What does that mean? We can find the influencers to these answers, and we can make links between the question just by looking at the data, not even applying common sense to that. The data is speaking to us, and it's telling that, okay, a psychologically healthy workplace is about raising awareness about mental health and supporting work-life balance and preventing harassment. That's what it means. And so this is fascinating when you look at your data with a new lens and apply the right techniques on it. And it's another case where you don't want to make prediction about the survey. You really want to understand what's going on. And our HR department has been super interested in that work. They use that work to build our action plan at NRC. Which brings me to lesson 7 about open data. The data that I just showed you is open data. It's freely available on the internet. Very often, in my experience, the data, it can be in plain sight and remain underexploited. And that's the perfect example. All the departments have seen that data for years and may not have made the same kind of links that we've made. I'm working right now with another department about leveraging business data, open data sources from other countries that may be useful to their own business processes. It's all there. It's all organized. You just have to download it, exploit it. But people don't do it for various reasons. And I think we need to be able to do that. And I was talking with Jean just before this talk, and he's building a data lake. And that's what the kind of things we have to do. We need places to ingest that data and exploit it. Another lesson, eat your own dog food, especially if you're in an IT organization or in an innovation branch or whatever, and you have to serve other clients as part of your department. You need to preach by example. You need to do what you want others to do. So yeah, if you're an organization focused on innovation, are you using AI? Are you using digital as part of your own business processes? Because if you're not, I would argue you're not very credible. And we've been trying to do a lot more of that at NRC and apply some of the solutions we build for others to ourselves, and vice versa. Sometimes we build stuff for ourselves and apply it to others, because there's a lot of synergies. All the government departments, they all have an HR department, they all have a finance department, they all have procurement problems, they all have infrastructure problems. And I think instead of reinventing the wheel all the time, we can collaborate a bit more and share some of these tools and experiences that we have. I'm going to give you an example. We, onboarding, and we all the departments have, well, many government departments have this tool called Assist with service tickets, and we use it at the NRC for onboarding tickets and hiring new employees and whatnot. So we have a tool now that allows us to figure out exactly what tickets have not been actioned on time when they were submitted on time, because often the issue is that people don't submit their tickets on time. So of course it's not filled on time, but if they do submit their things many days in advance and it's still late, we can identify very quickly what the issues were. And that's more traditional analytics, but we're now starting to build AI as well on top of that, so that we can triage the tickets automatically and route the tickets directly to the people who will action them, instead of having them wait in a mailbox or in a service center. Similar thing that we're doing, trying to apply to ourselves more, identifying early new technologies that are appearing in the scientific literature. Because needless to say that if I tell you right now that quantum computing is a big thing, or that mRNA vaccines are a big thing, you're gonna say, well, of course, yeah, mRNA vaccines, it's a big deal. But if you're an organization like the NRC or a defense organization, for example, you want to see these things coming 10, 15, 20 years beforehand, right? Because you want to invest in the right technology and become a leader and so on. And we've been developing things for other departments, including D&D, but also for some of our internal needs, to see these kinds of patterns coming. And this is, again, just starting. It's more at the research stage, but it's still very promising. We look at the literature in one field of research, for example, hypersonics. We look at almost 22,000 research papers published since 1985, and we try to see what's going on with all these papers. What are the research topics that are emerging before people notice? Of course, that's a lot of paper to go through. We cannot read all of that by ourselves, but AI is there to help now. And if you pick a model like BERT, there are some very, very strong language models that you can exploit and find, basically use to find weak signals in the data. And we've done that. We found some very interesting things in the field of hypersonics. We're going to continue with other type of technologies, but long story short, we were able, at least in one field so far, to identify patterns or signals of technologies that were weak a few decades ago, but that were interesting and that became very strong and very important in the field. Lesson number 9, and I have 10 and I'm almost done, but this is an obvious one. You need to understand the AI risk, especially in the government setting. You need to understand the fairness of the algorithms, the privacy side. If the decisions are automated, and if you give agency to a model, you need to really understand the implications of that automated decision making. And I think there will be some panels on that. Canada is actually doing very well on that front, trying to be very proactive. But my point is, the data science side is fun and interesting, but you always have to keep in mind, especially if you work with the data from Canadians or from citizens, you need to keep in mind all the risk related to your work. And I will finish with one last lesson that I've learned, which is about not focusing too much on process. I talked before about, you know, vendors trying to sell you new tools, new technologies, claiming it's the best thing and it's all automated and whatnot. The same thing is a bit happening with processes. So you're going to hear a lot about different flavors of agile, and there's a lot of rituals around these different processes, and every company claims that they have the best process to deploy AI quickly and whatnot. And again, it's not, well, I never found it was true, but I was a bit relieved when I saw this this quote by Michael Conlon, which is the former CDO of the US Department of Defense, was saying that when it comes to data science, we're all wigging it, even the experts, because this is applied R&D, there's no playbook. He said, forget about policies, memos, directives, standards, reference architectures. You know, don't add to the wallpaper, lead by example instead. I think, you know, maybe not everybody will agree in the government about that, but I still find it's important to lead by example. Start with concrete things that will deliver results, because you can try to find or build the best playbook, the best recipe that will apply to all of your AI models down the road, but I guarantee you it's not going to work. So you start with some guiding principles. You try to follow the rules, but don't try to build the ultimate process that will deliver all the AI that you need, because it doesn't exist. Frankly, it doesn't exist. So I'm reaching the 40 minutes mark. So I will leave it at that, saying that, you know, our AI journey is just beginning. If you follow the field, and if you've seen the kind of things that have came out recently from Google with their language model, from OpenAI with their language models too, like GPT-3 or DALL-E 2 with their image generation, it's really impressive what's happening in just a year or two. I don't know what it's going to look like in 10 years, but it's good. The next 10 years will be something, and we need to be ready for them. So on that note, I will pass it back to Jean, and welcome any questions that you have. Thank you.
What a great presentation. Thank you. That's great. A lot of lessons learned there. It's limited yourself to 10, but that's quite a lot. We don't have any questions from the audience right now, except basically viewers. So there's a number of us still watching. Yeah, just no questions. So we've got one question. Sorry. Let me see. What would be your view about AI in public sector versus private sector? For example, big companies are able to pay high salaries to grab the most intelligent people. What's your view on that?
Okay, I'll get to talent, but actually I had a lot of slides, so I didn't want to put too much there, but there's actually a lot of differences now that are emerging between the public sector use of AI and the private sector use of AI. And that's partly why the NRC decided to have an accelerator focused just on the government, because there's a lot of differences. And to serve the two different sectors, you basically need different skill set, honestly. On the private sector side, a lot more companies, for example, are now using imagery and sound and a lot of unstructured text. Government is still, and I'm generalizing here, but the government is still very much in tables and spreadsheets and databases, and so tabular data, you know, structured data versus unstructured. There's a big difference there. There's the responsible AI aspect of things. So as I mentioned, it's key for the public sector. You don't want to make bad decisions pertaining to Canadians. But in the industrial sector, if you build widgets, if you build, I don't know, if you build cars, like you can, your process can go wrong from time to time, and you're gonna lose a piece of equipment or whatever. It's not a big deal. Your focus is really on performance, and if you kill a few pieces of steel in the process, who cares? On the government side, you cannot just do that. You have to be very careful, and the performance of your model is not what's important. It's really the kind of decisions that you make, and are they fair, and so on, and you have to be very careful about that. And because the performance is a big deal, it doesn't prevent the private sector to go with very sophisticated ensemble methods, things that may not be explainable sometimes, but for some companies, they don't care, because that the outcome is just the prediction, and the consequences of the prediction are not that that important. Public sector is different. You have to be super careful about the kind of methods you're using, the explainability, and so on. So lots of differences. Now, if you talk about talent, talent is, of course, a tricky one, because there's a lot of competition. The demand for data scientists in particular is very high in industry. The salaries go accordingly. They're very high, and the government cannot often match these industry level type of salaries and conditions. What can we do about it? I'm not sure. I've seen a lot of discussions about that recently on Twitter, but and social media. But you could argue that we need to focus on other advantages that the government has. We have good conditions. We work for our collectivity, for the public service. There are ways to sell. There are ways to sell the government as an employer of choice, and a place where you can make a big difference. I think a lot of people will still pick that over high salaries. At the same time, I'm gonna be blunt here. You need as well to give these talented people the tools that they need to succeed. And when I see, and I've seen it, and I've heard young, very talented people who just joined the government, and now they want to do something cool, and they want to work on Python and R, and they're not allowed to do anything on their corporate network. Well, that's not setting people for success. And the first thing they're gonna say is they're gonna go back to their their colleagues at the university, and they will tell them that don't go work for department X or Y. So we need to be set up for success. It's not just about salaries, but it's not just about salaries, but we need to get these other things right, including the mandate and whatnot. Yeah.
Sorry to bring it in. We just have a minute left. I need to go and introduce someone else for another session. It's been great to have you here. What a great presentation. Thanks so very much for presenting the topic to everyone. Very much appreciated. Thank you.
Merci, Jean.
Okay. Well, and we see that there are additional questions in the chat, in the Q&A. Maybe if you want to ask them, there's some contact information here on the screen for you.
Thank you.
Have a great day. We'll have to just wait for the technology to catch up while I end this. Yeah.